Hello, grade 10s. So this is your what called annual teaching. Okay. Hello, grade 10s. So we're going to start with your algebraic expressions, and we're going to start with the first one here, which we are going to look into numbers. Okay. And on your numbers, we're going to start with understanding what types of numbers do we have. We have what we call real numbers and non-real numbers. What are real numbers? These numbers, you find them on the number line. Okay, so on the number line, you find them. So these are what we call real numbers, and non-real numbers on the number line, you can't find non-real numbers what we call on a number line. So they don't exist. Okay, so here we have under real numbers, we have got irrational numbers and rational numbers. Okay, so we're going to start with rational numbers. We're going to start with rational numbers, and you just understand that rational numbers, they can be expressed as fractions. Okay, they can be expressed as fractions. That's what you need to understand. They can be expressed as fractions. And now let's start with the bottom one. What are natural numbers? So these are under irrational numbers. Okay, so natural numbers are like counting numbers. Okay, counting numbers. You know, when you're counting, you start from 1. Okay, when it's counting, you always start from 1. So here our counting numbers are, your natural numbers are 1, 2, going up. Okay, so these are what you call natural numbers. But when it comes to whole numbers, we add a 0 to our natural numbers. Okay, so when we add a 0 there, we are going to start from 0, 1, 2, 3, going up until infinity. Then when it goes to integers, we are now adding the negative. Now we are now adding negative and positive. So here we are going to say, just say negative and positive. Okay, so these are, and they need to be standalone numbers, meaning to say here we can't have 1/2 as integers. No, we can't have it as a fraction. So fractions here, no fractions on these integers. Okay, so here we're going to start from negative. So it's from negative 1, 2. So we are saying we have added negative when it comes to integers. But now let's come to rational numbers. Now rational numbers, remember, we are including everything, but now we are going to add fractions. Now let's add fractions here. When we add fractions, we can have fractions from negative 1/2, negative 1/4, 0. But also here, remember, negative 1 is there. 1 of what call, maybe we can say here 1/2, then 1 going 2. So we are now adding fractions on the rational numbers. Okay, as a group of rational numbers. Now let's now look on this question here on the right. From the set -2, 1/3, 0, 5, identify natural numbers. So natural numbers, remember what we say, natural numbers start from where? These are counting numbers. So only 5 here is our natural number. So it's only 5 that is our natural number. -2 can't be a natural number. 0 cannot be a natural number. What about whole numbers? Whole numbers, remember we said they start from 0 going up. So here we're going to have only 0 and 5. Okay, those are our whole numbers. Now let's look at integers. Integers, we know that it includes negative and positive, and also 0 is part of the integers. So we're going to say here -2, 0, and what? And 5. Okay, so these are your integers. Now what about rational numbers? Now we're going to include the fractions. So we're going to say all the set, the whole set, all of them, they are actually part of the rational numbers. Okay, so now let's move on to the next one, where we are going to include now to understand rational and irrational numbers as well in terms of decimals. Now when it comes to decimals with rational numbers, let's start here with the root sign. Root, if it's a root of perfect square, it's a rational number. For example, here, root of 4, root of 16, this is a rational number. What about cubes also? perfect cubes. Okay, perfect cubes, meaning to say here we can cube root of 27 is also a rational number. What about decimals? When it comes to decimals, decimals needs to be terminating. Terminating, they do end. Okay, so terminating, they end. For example, here we can have 0.25. 0.25 is a terminating decimal, so we consider it as a rational. The other thing here that we need to understand, on our decimals, they can be repeating or recurring, repeating decimals. Repeating or recurring. When you're saying recurring, we can have an example of 1,252525. Now, in this case, we can see that what is repeating here is 25252525. So we can simply write it in short and say 1,25. Then you put 2 dots on top there. It means that the 2525 is repeating. Okay. Now let's move on to the irrational numbers. Now in irrational numbers here, we are looking at root of non-perfect square. Non-perfect square. Non-perfect square and also cubes. Very good example here. We can have a square root of 2. It's a non-irrational number. Square root of 7 is also a rational number, irrational number. Cube root of 9. So here, cube root of 9 is also an irrational number. So these are non-perfect cube, non-perfect square. Okay. Then when it comes to decimals, now decimals has to be non-terminating decimals. So here we are saying non-terminating decimals. Non-terminating decimals. For example, here we are saying these decimals, they continue, they don't end. Like for example, here we can have 1,23578 9 goes on like that. Okay, we call that non-terminating decimal. Then we can see that with the dot, it shows that it's not ending. Okay, then we also have non-recurring, non-repeating or non-recurring, non-repeating or non-recurring decimals. Okay, non-recurring decimals, these don't repeat themselves. Okay, so for example, here we can have 1,37894. Okay, so in this case here we can see that no number here, we don't see any repeating here. Like for example, what we have here, we have got 1,252525. Here we just have numbers that are not repeating, and we call that irrational numbers. Okay, so and another thing again, pi is also another irrational number. Pi is another example of irrational number. Okay, so I think now we understand this. Now let's try to attempt these questions here. State whether the following numbers are rational or irrational. So here for the first one, 0,11, this dot here means what? It means that we have got 1 repeating, so it means that this is the rational. Then 1,025 is rational because it's terminating, it's ending. Then 3,137,496, we can see that it's irrational because it's non-recurring. Here 0,12535353. What we can see here is that we have 0,1253. Then we can put the dot on top there, meaning to say it's repeating now after the 1, 2. So this one becomes our rational. Then here 2,46, you can see that it's not ending, it's non-terminating, so it means that it's irrational. Then here root 5 here, it means that here is a non-perfect square, so in this case here it's irrational. Okay, now let's move on to the next one. real numbers. We now understand the real number that they do. We do find them on the number line. But now let's look at non-real numbers. Non-real numbers, very good example of non-real numbers is root of negative. So let's say root of negative, what you call negative 9. Root of negative is actually gives you what is it? A none. We can't have root of a negative. Even if we try to check here, root of negative 25, we know root of 25 is 5, but here we can see that is an error. Then another thing here, we can also have what we call undefined. When you're talking of undefined, just know that we are having a denominator as 0. For example, here we can say 1 over 0. We can also say maybe 3 over 0. So this mean that it's undefined, but it's also part of non-real numbers because these numbers, they don't exist. Okay, so in this case here, determine whether the following numbers are real, non-real, and undefined. The reason why I bring this undefined, so that when you meet it, you must know that it has to be below a denominator has to be 0 for it to be undefined. So here it's unreal, it's undefined. Okay, so here it's undefined. Then 3 over 7, this is an improper fraction. Okay, so improper fractions are also part of what you call rational numbers. So here it's real and rational. So real and rational. Okay, then here 3 over 7 is a fraction. It's also real and rational. Then root negative, remember we say it's non-real. Then here root of negative, remember non-real. Even if you put a square outside, it doesn't matter. We have it as a non-real. Then here it's real, but it's rational. It's irrational, okay? Because it's pi, real, and irrational. Okay, so I hope you guys understand the lecture. Don't forget to subscribe on the channel and also what call join the classes, the Google Classroom class, so that you can have access to the PDF of the notes of this, and also have the video at any time, access the video at any time. Okay, until next time, guys, thank you so much. All the best.